Okay, what we're going to take a look at in this tutorial is how to graph an exponential function. And let's start by talking about the characteristics of the graph of any exponential function. I put three things here. We have two key points, the key point 0, 1, and then 1 and the base, and then the asymptote is always going to be y equals 0. We'll talk in a minute after we've had a chance to graph this. We'll talk about the different transformations that we could run into. But these three things, the two key points and the asymptote, are extremely important. You've got to commit those to memory if you're going to graph any exponential function. So let's take a look at this example. F of x equals 2 to the x. So the very first thing I want to do is I just want to go ahead and draw in the asymptote. As I put up here, the asymptote is going to be y equals 0. So I want to use a dotted line at y equals 0 to graph that asymptote. So let me go ahead and do that. Keep in mind that with an asymptote, what that means is that's the line that I'm going to follow out towards, in this case, negative infinity. So as I get out to the far left, I'm just going to follow that asymptote. I'm not going to drop below the x-axis in this case. So next, I want to go ahead and write my two key points. So I know I'm going to have 0, 1. And since my base is 2 in this case, I'm going to have the point 1, 2. So those are my two key points. So all I'm going to do is I'm going to go onto the graph and I'm going to plot them. 0, 1 and 1, 2. Now the graph of an exponential function is going to be a curve upward. So in other words, I'm going to follow the asymptote and then just curve up like that. So that's exactly what I'm going to do as I draw my graph through those two key points. I'm going to follow the asymptote, and then I'm just going to curve right up through there, and I'm done. So that is the graph of f of x equals 2 to the x. That's it. And if I were to bring up a graphing calculator, I can see that that's exactly what I see. All right? Now, let's talk about some transformations. We've got really four different kinds of transformations. We are going to see shifts up, down, left, right, and we're going to see reflections over the x-axis or over the y-axis. So let's go through each one. So the first thing I'm going to do, since we just graphed 2 to the x, I'm going to go ahead and draw that one in real quick. So I'm going to plot 0, 1 and 1, 2 and draw my curve upwards. Okay, so there's 2 to the x. Now let's go through the different transformations that I've laid out here. Let's start with the blue one, y equals 2 to the x minus 3. So what I want to do is I want to think about what this negative 3 is going to do to the graph. Now, hopefully you've already gone over transformations of other types of graphs, quadratics, cubics, things like that. So what we should remember from that is any sort of addition or subtraction being done on the outside of a function is going to either shift it up or down. So I'm either going to have a shift upwards or downwards when I'm either adding or subtracting a number kind of off to the side. In this case, since I'm subtracting 3, that means I'm going to move my graph down 3 units. So that's going to force my two key points to go down 3. So I'm simply going to take my two key points, I'm going to move them down 3. 1, 2, 3. And 1, 2, 3. Now the other thing I want to take into account is since I've shifted my two key points down, my asymptote has to move as well. So instead of the asymptote being on y equals 0, I have to move it down 3. So now it's right here. So now the asymptote is at y equals 3. Sorry, y equals negative 3, apologize. Now I'm just going to go ahead and draw in the curve, exactly like I had done with the original. So that's it. Done. So that blue graph is y equals 2 to the x minus 3. Okay, now let's go to the red graph here that says 2 to the x plus 4, but notice how the x plus 4 is in the exponent. So that's going to be a different kind of shift. I always tell students when I'm inside the function, in this case when I'm inside the exponent, that's going to move me either left or right. We always have to do the opposite of what the sign is. So in this case, since I am plus 4, I'm going to move to the left 4 units. So anytime we're in an exponent like that, we're going to have to move the opposite direction. Since it's plus 4, we're going to go to the left. If it had been minus 4, I'm going to move to the right. So I'm going to take my 2 key points, and I'm going to move them to the left 4. So 1, 2, 3, 4. And 1, 2, 3, 4. Now keep in mind that since I'm simply shifting to the left, my asymptote has not moved. My asymptote would only move if I was shifting up and down like we did in that blue graph. But since I'm only moving to the left here, my asymptote does not move off of y equals 0. So now I have my 2 points plotted, and I'm just going to go ahead and draw my curve. That's it. Okay, let's move on to the green one. What if I had y equals negative 2 to the x? Okay, well, let's keep in mind that... Oh, let me undo that for just a minute. I only want to erase the red one. Okay, there we go. So now I'm going to move on to the green one. So now we're going to get into reflections. The bottom two, the green and then the black one on the bottom, those are reflections. And these can be a little bit, I think, a little bit tricky to keep track of. So let me revisit the blue one. Notice how with the blue one, since that minus 3 was not in the exponent, that moved it down. So what I need you to think about is when things are on the outside, in other words, not in the exponent, that's going to affect the y value, not the x value. So since I have a negative out in front, that's going to affect the y value. So I don't need to change the x's, I need to change the y's. So what I'm going to do is instead of going 0 positive 1, I'm going to go 0 negative 1. Instead of going 1 2, I'm going to go 1 negative 2. So that's going to be a reflection over the x-axis. Sorry, my writing isn't very good there. But it's a reflection over the x-axis. So let me repeat what I just said there. When things are not in the exponent, those are going to affect the y's. In other words, up and down and reflections over the x-axis. Your x's will not change at all, only the y's. So now that I've reflected those 2 points, I'm going to have a curve downwards. And you can see that basically what I've done with that black graph is I've just mirrored it over the x-axis. And that's all. So that takes care of the green one. Now let's talk about the last one, which is if we had a negative inside the exponent. So in that case, think about what we just said. If we're on the outside of the function, that affects the y's. So if we're inside the exponent, like this negative x is, that's going to affect the x value. So since I have a negative in the exponent, that's going to affect the x values. So what I need to do is I need to reverse my x's. So if I have a positive 1x, that's going to become a negative 1. Now, in the case of 0, it's going to stay exactly where it is. Because if x is 0, if I were to make it negative 0, that doesn't change it at all. So it stays exactly where it is. So what I'm going to have, instead of a curve up to the right, I'm going to have a curve that's going in the opposite direction. So now we have a graph that looks just like this. So what that is that represents a reflection over the y-axis.